Welcome you all. Today we are going to do the CFD simulation of fluid which is flowing through a Venturimeter. As we are aware, the Venturimeter is a device which is used for measuring the discharge of fluid which is flowing through it. So we have a converging cone, then we have throat, and we have a diverging cone. The length of the divergent cone is 3 to 4 times longer than the convergent cone in order to avoid the tendency of breaking away of fluid, as well as to avoid the eddy losses. So this is same diameter D1, this is same diameter D1 over here. At a throat we have less diameter, so we are trying to do the CFD simulation of this Venturimeter over here for today's session. So starting with the ANSYS workbench, so click on your workbench. So we are going to use the fluid flow fluent as a analysis system. First of all, the first phase will be to prepare the geometry of a Venturimeter, then preparing the mesh, and then applying certain boundary condition in terms of velocity. So this is how one by one we are going to do for today's session. So first of all, starting with fluid flow fluent. So starting with a design modeler. So click on the design modeler. You will see the starting design modeler option available here. So first phase will be to focus on selecting the units. So click on any one of the XY plane. So here you can observe red X, green Y, and blue is your Z. So I have set the units in centimeter. So first phase will be to create a primitive. So first of all I am creating a cylinder over here. So this is a cylinder which I have prepared. The radius I have taken, that is equal to 10 centimeter. If you want, you can make it somewhat different over here. So first of all we are taking this Z component to be equal to 20. So this is the portion of pipe which we have taken. Now I will try to make it generate, make it frozen, and we'll click on generate. So I have created this as a cylindrical object. Right now I have created this as a solid object. Later on I am going to make this as a hollow object. So this is how the object look like. So one more time I am going to take a primitive over here. So understand what is the radius. So this is the radius which will be useful for us when we are preparing the further section of your Venturimeter. So one more time I am going to take a cone. Now the cone is oriented in this direction. I don't want in this direction, I want in negative direction. So I will specify -10 over here. You can see the object is extruded in the other direction. So the base radius is 5. I will take the top radius, say for example equal to 2 centimeter. So make it like this. If you want, you can take it some different radius also. So I have taken this as a equal to 2 centimeter as my length of my converging, top radius as a 2 centimeter. Length of a converging cone is 10 centimeter. So make it generate. So this is the portion which I have generated. Now next thing I will go on to make use of one more time, that is a primitive. Again I am taking cylinder. So the cylinder has been generated here. I don't want this to be here, I want at this place. So we need to shift the origin over here. So again this is in positive direction of Z. I don't want this to be in positive direction, I want in the negative direction of Z. So I will specify there. So radius I will specify as equal to 2 over here. Now next thing is I want to shift the origin. So just check it out, Z, I want to shift the origin by, that is equal to -10. See whether your object is shifted over here. So this is a portion which is of throat. You may change this Z component. Say for example if I want this is to be equal to -2, accordingly I can specify. So this is the portion, make it add to frozen over here like this. So make it generate. So this is the portion first, second, and this is third. Now what I will do is I will try to create. Now this is the dimension which I have taken was 2 centimeter over here along horizontal. This was 10. Now I have to create one more cone. So one more time I am going to create a cone. Now where I want this cone, again I don't want this cone in this direction, I want this cone to be available in the other direction. So I need to shift this cone by z coordinate. So I will specify minus 12 because this is 10 and this is 2. So specify minus 12. So you can see here, now I will shift this z component to be equal to minus 40. Why minus 40? Because the length of the divergent cone is 3 to 4 times longer than the converging cone. So that's why I specified this as a 40. Base radius I have taken 2, and the top radius I will the top radius is equal to 2. Base radius over here, that is here 2 centimeter. Top radius I will take is, that is equal to again 10 centimeter. So let's make it generate. Sorry, not 10, it is equal to, radius is equal to 5 centimeters. So you can see the converging part has been prepared. So make this as a add to frozen and generate. So this is the first part, this is second, and this is third. The length of diverging cone is made 3 to 4 times longer than the converging cone. This is we have taken 10, this we have taken as a 40. If you want, you can modify this to 30 also. Say for example minus 30. Make it generate. So this is 10 and this is 30. So you can see first cone, that dimension I have taken in the z direction is minus 10. So again one more time I am going to create a primitive, that is cylinder. So cylinder, here you can see it has been generated here. I don't want this to be here, I want with radius that is equal to 5 over here, but I want to shift by here. So at what distance I should shift this? I should shift again by considering first of all the length. So this is z component, I will specify minus 20. So it has been shifted here. Now I need to shift the origin. To what distance? This is 10, this is 2, and this is 30. So 30 plus 40 plus 42. So I will shift by minus 42. Just check it out where it goes. So it goes here. So make it generate. So make this as a add to frozen. So now we have prepared a geometry. First one, this is a pipe, then converging cone, this is throat, and this is your diverging cone, and again it is your pipe. So as per our diagram. Now what I will do is I will make this as a uniform body. So for this I am going to make use of Boolean operation. So select all bodies, make it apply. So 5 bodies are there, make it generate. So this becomes a uniform body. So why I have prepared this as a uniform body? Because I want to make this as a hollow, and before making this as a hollow I will, and doing the fill operation, I will ensure that these edges are we can say attached with respect to each other, so as to avoid errors. Now next thing is to make this object as a theme. So click on the faces to keep here and select the individual faces. So these are the faces which you want to keep. You can specify the thickness 1 centimeter over here, or you can keep it 0.5 centimeter also. So make it generate like this. So you can see the Venturimeter becomes hollow from inside. So this is a converging and diverging part, make it generate. So here what you can see, this is a solid body. Now next thing will be to feel the fluid inside, because computer doesn't understand which one is the pipe, which one is the fluid flowing. So for this I need to go with one operation which is called as feel. Here option I am taking as a cavity. So select internal faces. So we have selected all internal faces, and then make it apply, and then make it generate. So in front of fill it is right click, so it means whatever we have done is correct. Now again this is a part which is fluid. So which fluid is flowing? Say for example I say water is flowing. So accordingly I will select water, and this is, I will say, pipe wall. I will say this is pipe wall. So specify boundary condition over here. So this is the first thing which I have generated. Now next thing is to proceed further. So we have prepared the geometry of Venturimeter. Now it's next step will to proceed further for your next part. So let's move to the meshing. So in meshing we'll try to generate a default mesh first. You can modify the mesh later on also, but I will prepare a default mesh so that the time required for calculation will be less. Next thing will be to specify the names, because computer at its own doesn't understand which one is inlet, which one is outlet, and which one is wall, and that's why it is very important to specify the names. So first of all, this one I will select this face as inlet. Then this face as a wall. And the other face as a outlet. So we have done three things. One, it is inlet, outlet, and wall. One more time, click on update. You will see message, the mesh translation to Fluent is successful. Now you can close your meshing and go back to your workbench. Check out, in front of mesh it is right click, in front of geometry it is right click. So next part is setup. In setup, depending on number of cores, you can select 1, 2, 3 or 4. Make it start. So here the things will be to apply the boundary conditions, to specify the material. Over here, specify the velocity as a boundary condition over here. So first of all, I'm going to specify this as a steady, because I'm not going to use energy equation, so that's why I'm not going to use the transient. You can specify gravity over here minus 9.81. See, this is a positive direction, so gravity will act downward. So these are the arrows which shows the fluid is coming in, fluid is going out. Now next thing is specifying the model. So in case of the model, I'm not going to change anything. Then I'm going to specify the fluid that is equal to water. So Fluent database, I'm going to use water liquid. Make it copy and then it is close. So if you want, you can change the pipe material also, but I am keeping here aluminum as it is. Then going to cell zone condition. So here also I am not changing any of the boundary condition. Next, here I will specify velocity at inlet. So let's specify some velocity, say for example 2 meter per second at inlet. Then close this. Now this is how the boundary condition which we have specified at inlet. Then go for reference values. Again, tell from where to start. So I will say compute from inlet. Now which zone? I will say water as a working field over here. Then go to the initialization. Again, go for standard initialization, compute from inlet and make it initialize. So once this has been done, you can proceed further. Say calculation activities. You can specify this autosave, say for example 20 over here. Then go for run calculation. Then you can specify the number of iterations, say for example 500 over here. Then go to the graphics part, and in the graphics part select the path lines. I want to visualize the velocity, so select velocity. Where I want to visualize inlet, outlet and wall. So I have specified inlet, outlet and wall. I'll make it save display. So this is how the things will be generated. If you want to check what things are happening is correct or not, you can click on pulse. So in this case, this fluid is going, the portions are going ahead. So that means whatever you have done is correct. So you can make it save display and you can close this. Then the thing is to start your iteration. So click on calculate over here. So it will take time depending on your system configuration and depending on the quality of mesh you have selected. If you have taken a fine mesh, probably the iteration process will take more time. Okay, so this has been completed. Now just go back to Workbench again. You will see right click in front of setup, right click in front of solution. Now it's time. You can, if you want, you can close the Fluent window over here and click on your result, what you want to visualize. So you have to ensure that in front of each and every them right click is there. Then specify a wall, specify some transparency over here. Say for example, I will specify 0.9, make it apply. Then similarly, pipe wall, you can set transparency over here 0.9, make it apply. Then inlet, you can set transparency over here, say for example 0.9, make it apply. Same way at the outlet, set the transparency to equal to 0.9, make it apply. So this is how the geometry has been prepared, and we say the things are visible in the, we can say, post processor data. Now it's time to select a streamline over here. So click on streamline, make it apply. From where to start, select inlet, make it apply over here. So you will see this velocity streamline on the left hand side, that will show you where the velocities are maximum and where the velocities are minimum. So accordingly it can be observed. Now just you have to select the sweep animation. So streamline one, you can make it slow over here. There is an option of saving this files in terms of HD video, or you can select the other also. So if you select save movie, this will save the simulation. Just I will try to show you how the simulation runs. So click on the play button. You will see the fluid is flowing. Then here the velocity increases and the fluid is leaving from inlet to outlet. So this is how the simulation that can be done. You can save the simulation by clicking on save movie over here. So whatever the required folder is there, in that folder it will be saved. So this is how the CFD simulation that can be understood with the help of we can say Venturimeter. So you can observe the velocity on this left hand side, and accordingly we can understand the whole process, how the fluid will behave when it is passing through the Venturimeter. So one more time, just observing the things, you can increase this number of particles. We can either we can say increase or decrease the number of particles over there, as well as you can change the size